a project that I'm doing with my lab partner, Saifu, and my mentor, Dr. Akshita Sai. Basically, we are going to do data analysis and Internet of Things, which is the process of first extracting data by collecting human activity recognition, which we'll go over in a little bit, collect that data, then we're gonna format the data and analyze it. So, I'm gonna do something a little bit different here. I'm going to discuss one of the main things that we are going to focus on, which is human activity recognition, which is short or long for HAR. So what is human activity recognition? What is HAR? It refers to the sensors that are used in mobile devices that tracks and recognizes simple human actions. So we have this thing over here. We all have this nice piece of technology, the mobile phone, as well as tablets, laptops, and other various mobile devices. Well, look at that, I moved. So it's gonna collect the data through human gestures. This phone's gonna be like, oh, Skyla just moved. So then now, next, we're going to go to the brain of the device. So basically, it'll activate the sensors, and it's gonna go into the deep learning algorithm. So it's gonna be like, all right, Skyla has just moved. It's going to be like, all right, what kind of movement did Skyla just do? So it's gonna be used in convolutional neural network and long short-term memory, which again, in basic terms, the brain of the device. Then, after that, the magic begins. Human activity recognition. So now, if I were to just stand here statically, the phone's gonna be like, okay, Skyla is currently standing. If I am walking, the device is gonna be like, all right, Skyla is walking right now. If I am sitting down, right over here, the device is gonna be like, all right, Skyla is sitting down. And other various activities that I do. So, in short, why is HAR important? Like, why does this all matter? HAR is important because it can be applied in devices and technologies in certain fields, such as security, sports, health, gaming, smartphones, and so forth. This project is important because we are able to analyze the data and to just see the trends and what happens with the activity on how we move. So if you are interested in this, you can meet us at room 266 to learn more. Thank you. I didn't quite hear that. May you please repeat that?
How does the sensor data accurately impact the recognition model?
So how does the sensor data actively recognize the human models? That's a great question. So the sensors are able to recognize the human models because, again, through the deep learning algorithm. There's actually 6 different kind of sensors. You know how we have all our human senses to also recognize our environment? Well, the 6 sensors are accelerometers, gyroscopes, magnetometers, rotation vector, linear acceleration, and gravity. If you want me to speak it in simple terms in English, it's just, again, the 6 senses of the device. So using those different kind of sensors, it will recognize our movement using the X, Y, and Z axis. Thank you for your question, Faith.
An example of this is like a Ring doorbell camera. It's equipped with a motion sensor and a video camera that's able to send signals through the house's Wi-Fi that the user can see and can activate.
All right. Another thing that we are also going to review is human activity recognition. So, human activity recognition, HAR for short, refers to the sensors that are used in mobile devices that tracks and recognize simple human actions. So, here is the visual representation of the process. First, it's going to collect data through human gestures. So, something such as, a device such as a mobile phone, a smartwatch, a laptop, and a tablet will collect the data through the human gestures. As you guys can see, I am now making some movement, and my phone is like, wait a minute, I just sensed that Skyla made this movement, which goes into our next step, activating sensors and deep learning algorithm. Systems such as convolutional neural network and long short-term memory is used. In better words, this is the brain of the device. So after that data goes through, now it's going to output the human activity recognition that it recognizes. So, you know, again, if I'm walking, my phone will sense, all right, Skyla is walking right now. If I am sitting, my phone is gonna sense, Skyla is sitting right now. If I am standing completely still, no movement, nothing, my phone is gonna sense Skyla is standing right now. And the reason why HAR is important is because it can identify a range of human activities, and because of its advanced technology, it can be applied in devices and softwares used in certain fields. So now we're also going to go over the sensor overview. We all have 5 senses that help us navigate the environment as well as survive. So the devices also have senses, except that they have 6 senses. So sensors are built into the device's hardware and software to measure the orientation, motion, and environmental conditions. They are capable of providing raw data with high precision and accuracy on 3-dimensional movement and positioning using the X, Y, and Z axis. So, as you can see, again, we have 6 senses. The most important ones are up here, the 3 most important ones, which are accelerometer, gyroscope, and magnetometers, which we will go over the data later on, but there are other sensors such as rotation vector, gravity, and linear acceleration.
Now moving on to an overview of our methodology, we first started with data extraction, which basically had us working with a mobile application that our mentor provided. We analyzed the code and saw how it accessed the sensors in the phone and how it would work with the next step, which is our data collection step, where we basically went out and collected data for movements like walking, sitting, or walking upstairs. After this, the data was then imported into a spreadsheet where we then did a little bit of formatting before we then imported it into a virtual environment in our data analysis step, where we used Python and a bunch of its libraries and extensions to properly filter the code and create visualizations that we could draw insights from.
So we're going to go through one of the first steps, which is data collection. The data is collected through an app that our mentor developed on the project phone, which is a Samsung Galaxy S21 Ultra, S24 Ultra. 3 to 5 minutes of activity is logged in each file that we created. As you can see, this is an example. Both Saifu and I did this, again, we write down the kind of activity that we were doing, such as sitting, walking, climbing, and all of that is recorded into a comma-separated value.
And then the next step is data extraction. In our data extraction process, we basically took that sample phone, connected it back into our laptops, and saved the files locally. The CSV files were viewed and stored through Android Studio's Device Explorer, and we could again save it locally for further analysis and processing.
Then we're going to go through the bulk of our process, which is actually the most crucial one, data analysis. The files are uploaded on Microsoft Excel for further organization and conciseness. So what we do here is delete the first 30 and the last 30 columns to remove any inconsistent and null values. And we also label our activities. So for example, 0 for sitting, 1 for walking, and 2 for climbing. Then after that, after the data organization, we upload these files on Jupyter Notebook and we read them into our Python scripts. So as you can see, we're using a method on the Python library called PANDAS, which is a programming language for data manipulation and analysis. And as you can see, I have some commands here to see all the kinds of details of the data. For example, this is a tail of data here, this is the head, this is in, and this is what I use to get the data.
And this is basically the data we were able to format and visualize. I'll be giving like a brief from peeking at the data, you can see something that you may seem as irregular. For our sitting data, there's a lot of spikes and bursts compared to our walking upstairs data, which you'd expect to have a lot more of these spikes because you're actually like moving the phone going upstairs. But the cause for these spikes could be just scratching your face or like scratching your leg while holding the phone, because it's tracking the data, it's reading in data relative to the phone, not relative to like what you're actually doing. While compared to our upstairs, while we were probably gathering the data, we were holding the phone in a more constant position. And for our walking data, it's what you'd expect. It's a lot more rambunctious, a lot more spikes in the values. It could indicate turns, change in elevation, and other movements that we might have been doing while we were walking. And this is our gyroscope data. It's also relative to our accelerometer data. So a lot of the reasons you may see the ups and downs in this is because of the same reasons you have ups and downs in our accelerometer data, like because we're scratching our face, like, and the gyroscope is like a rotational sensor, so it would track like when I'm like rotating the phone while I'm scratching my face, rotating the phone while I'm doing whatever while doing these movements. And then the magnetometer tracks the magnetic field relative to the phone, so it's basically just dependent on the orientation of the phone at the time. Like it could have better magnetic readings in a specific orientation, facing that way. It just depends on how strong the magnetic readings are, depending on the orientation.
Now we're going to compare our data. So as you can see, here's Saifu's graphs and there's my graphs. The sensor that we are going to specifically measure is accelerometer. So as you can see, I'm shorter than Saifu. I'm 5'1", Saifu 6'4", and also Saifu walks faster than me. So you can see, like with Saifu's, the trends are a little more drastic. The spikes are a little more defined with the walking on each of the axes. As of for mine, it's a little more smaller, not much dramatic change here. But again, it is a reason why like our data is similar because it's measuring the accelerometer sensor and how we walk specifically. So again, you can compare and contrast for a bit here, but that's how our data looks.
And now moving on to our research applications, a more like daily use or daily way we use HARs, like in our mobile devices. Like for our device orientation, depending on how you have your device set up, it may reorganize the content to fit the screen better depending on your orientation. And also prices, detection of features, like how Apple Watch, especially for elderly people, their fall detection features where if you were to fall, your watch could detect that and possibly contact emergency help. Another more personal use is fitness tracking, for tracking how much steps you might have taken in a day, how much elevation you climbed in that day, and how much calories and your heart rate, what that might have been. And another use in a different field, actually in the healthcare field, is remote patient monitoring. It's basically just being able to monitor a patient's, like whatever is going on with your patient through basically like computers and basically like the machine learning models. The patient monitoring remote patient monitoring can be scaled, especially using computers, so it'd be readily available for more people, and it would just increase the benefits that a regular person could receive. That's all for our presentation. Thank you for listening, and are there any more